Okay, 17 is the first question that I assigned. So we have a car who overtakes a cyclist. Writing, so we have, let me write this down. Car, speed is 48. The cyclist is 12 miles an hour. Okay, that's my rate. Time-wise, time-wise, time-wise. The cyclist had a 3-hour lead, so he's going to be the t plus 3, which means the car is going to be t. Okay, so that's my table. We multiply, we get the distance, 48t, and here we get 12t plus 36. How far from the starting point does the car overtake the cyclist? So here's a cyclist, he takes off first, right? Here's a cyclist for CY for cyclist, and then the car takes off, right? And then at some point the car will pass the bicycle. So this is, what's that distance? So at this point we know that each distance equal each other. So 48t equals 12t plus 36, 12t plus 36. We're going to subtract 12t from both sides. And we're going to get 36t here equals 36, and divide both sides by 36, obviously here. T equals 1 hour. So in 1 hour, the car overtakes the cyclist. So that means how far from the starting point? Well, if you think about it, distance equals rate times time. So how far did the car drive to overtake the bicycle? Well, his speed was 48 miles per hour, and that's how you write it, times the time. How many hours did it take? Well, the car took only 1 hour, times 1 hour. So if you actually were to write everything with the units, this is what it would look like. So when you multiply this, the h and the h goes away. We multiply 48 times 1, which is 48, and the units miles. Says that's what we get. So 17, how far from the starting point, or from the, it would be 48 miles. Okay. 18, plane. Okay, so jet plane traveling 6. Okay, so we have a jet plane who's traveling at 600 miles an hour, overtakes a propeller plane. I've been in one of those. Propeller plane that had a 2-hour head start. The propeller plane is traveling at 200 miles an hour. This is my R, the T, and the D. Now, if the propeller airplane had a 2-mile head start, his time is going to be T plus 2. Meanwhile, the jet is going to be just T. Again, same type of question, how far from the starting point? So let's, how long, what's the distance that the jet plane had to travel to overtake the propeller plane? Well, the distance here is 600t. The bottom one is 200t plus 400. We know that at the point where the jet overtakes the propeller, the distances are going to be the same. So 600t equals 200t plus 400. Minus 200t from both sides, and I think we're going to get 1 hour again. This is 400t equals 400. So the time-wise, divide both sides by 400. And in 1 hour, the jet plane catches up. So, how far, and what was the distance that the jet plane traveled? Well, if you go to our formula here, distance equals rate times time. We know the jet traveled at 600 miles per hour, and if he travels for 1 hour, how far did it go? Well, the hour and the hour cancels. 600 times 1 is 600, and we get 600 miles. So for 18, it took 600 miles for the jet plane to catch up to the propeller train. All right, so far so good. Those simple questions. 21, running out of an average. 21, sorry. 21? Yeah, 21. A motorboat leaves a harbor. Alright, so leaves a harbor 18 miles to an island. The average speed of return trip. So, going and returning. So going to the island, I guess it was 18 miles an hour. RTD. Going back from the island was 12 miles an hour. How far was the island from the harbor if the total trip took 5 hours? So it took 5 hours, so let's call one either the going and the returning t, right? It took this many hours to return, so the going part obviously is going to be 5 minus t. So now we can get our third column. So 12 times t is 12t. 5 is 90. Minus 18t is the going part. So we know that the distance going, the distance returning is the same. So that's how we set up our equation. 18t equals 12t. We're going to add 18t to both sides. 90 equals 30t. Divide both sides by 30. And t equals 3. So returning took 3 hours, and obviously going took 2 hours, right? Let's circle that. So, and what do we want to know? How far was the island from the harbor if the trip took 5 hours? Okay, so again, distance equals rate times time. So the going part, he traveled at 18 miles per hour, and he traveled for 2 hours. So the distance that he traveled in 2 hours, it's obvious, would be 36 miles. So whether you did that using the going speed or the returning speed, and if you look at the return, again, the return part, he was traveling at 12 miles per hour, and it took him 3 hours. Hour and hour goes away. 12 miles times 3 equals 36 miles. And it makes sense, right? Because the distance is the same. 22. But I feel like I just did this. No. Boat leaves the harbor and travels an average speed of 9 towards a... Didn't I just do this? No. Okay, so no, I didn't. Towards a small island. So let's go going. Let's call it going. It's going 9 miles an hour. 2 hours later, a cabin cruiser leaves the same harbor and travels an average speed of 18. So, all right, so I see there's 2. So let's call, what is it, motorboat? And we'll call it the cabin cruiser. The motorboat travels at a speed of 9. The cabin cruiser's speed is 18 m. 2 hours later, the cabin cruiser left. Okay, so the motorboat is t plus 2, and the cabin is just t, the cabin cruiser. No idea what that is. And okay, so far so good. And how many hours after the cabin cruiser leaves will the cabin cruiser be alongside the motorboat? Okay. In how many hours will both two distances be the same? Let's find the D. 18 times t is 18t. 9 times t is 9t. And 9 times 2 is 18. Okay, so that's how we set up our table. Okay, so when will the distance of each of the cabin cruiser and the motor be the same? And that's how we set up our equation. So when their distances are the same, we can set the equation as this is equal to that. 9t plus 18 equals to 18t. Minus 9t on both sides. We get 18 equals 9t. Divide both sides by 9. And t is 2 hours. So t is 2 hours. I can go back here, which means that the cabin cruiser is going to travel for 2 hours to catch up to the motorboat. So yeah, that's it. Oh, it's 2 hours. All right, that's it. Oh, okay. 22, we just did 24. 2 trains, and they're going in opposite directions. One is 6 miles. If the rate of one is 6 miles per hour more than the rate of the other one. Okay, so we have train A, train B. You can call it a slower train, the faster train. It's up to you. So I know the train A travels at R. That rate, that's the rate. And then the other one's 6 miles faster, so we're going to call that R plus 6. Okay, and then they travel for 4 hours. RTD. This is going to be 4r. This is going to be 4r plus 24. What do I know about the distances? After 4 hours, the distances, they are 160 miles apart at the end of 4 hours. So you think about it. Here's a train going this way. Here's a train going the other direction. After 4 hours, you press on the brakes, they stop. We know that this distance then is 168 miles. So I can write that the distance of train A, which is this one, plus the distance of train B, which is this one, equals to 168. So that's my equation. 4r plus 24 equals 168. 8r plus 24 equals 168. Divide both sides, subtract both sides by 24. We get 8r equals 144, I think. Divide both sides by 8. And 8 equals 18. Yep. R equals 18. So what do I want to know here? What is the rate of each? So the rate of slower train is 18 miles an hour, and the other one's 18 plus 6, which is going to be 24 miles per hour. That's 24. 24, 25. As part of a flight training, a student pilot was required to fly to an airport and then return. Okay. So we're going to call it going again. We're going to call this the return point. Those are my two. All right. RTD. So going was 100 miles an hour, and the average speed coming back was 150. Maybe he had the wind behind him. Find the distance between the two airports if the total flight was 5 hours. Okay, so the total flight is 5 hours, so we can put 5 here. Wait, sorry. Let's call the going t, which means the return is going to be 5 minus t. Multiply the two columns to get our distance, and right now the distance is represented by 100 t, and here it's going to be 150 times 5, which is 750, minus 150 t. Okay, so we know that their distances here are going to be the same, going and returning, so we can write 100 t equals 750 minus 150 t. Plus 150 t on both sides. Then we get 250 t equals 750, because these two go away. Divide both sides by 250, and t equals 3. So going took 3 hours, and coming back, it took 2 hours. But what's the equation for? Find the distance between the two airports. Now, it doesn't matter which you use here. So let's say the going part. Let's use the going part. So distance going. We traveled at 100 miles per hour, right? Times how many hours did he fly for? 3 hours. So what's the difference distance covered? So h and h goes away. 100 miles times 3 is 300 miles. So that's the distance traveled. What number is this? 25. 27. One more. Again, sorry. There's a car whose speed is 56. A cyclist whose speed is 14. The cyclist left first, so he had a 3-hour head start. So RTD, time-wise, who had a head start? The cyclist had a head start, so we can call 3 hours head start, so t plus 3. The car is just t. This will be 56t. The bottom one will be 14t plus 42. How far from the starting point does the car overtake the cyclist? So first we gotta find t, right? So 56t, I know that their distances are going to be the same the moment the car reaches the cyclist. So 56t equals 14t plus 42, minus 14t on both sides. And I'm going to get 56 minus 14t is 42t equals 42. Divide both sides by 42. And I get t equals 1 hour. So after 1 hour of driving, the car catches up to the bike. Yeah, that's really fast. So what's the distance? Well, the distance, think about distance equals rate times time. So the distance, 1 second please. Hello? Hi. Hi, how are you? Sorry. So distance equals the rate, and the rate the car is driving at 56 miles per hour. And he's driving for 1 hour, right? Because that's what we found. So if we multiply those two, well, 56 times 1 is 56, and obviously miles, because the h and the h crosses out. So the distance, how far from the starting point did the car overtake the cyclist is 56 miles. Okay, so I think you're a little bit better today than you were yesterday. All right.